We're now entering the second part of the event, and I couldn't be any happier to have the chief himself present the KNX Secure specifications, the extension to the KNX standard to the audience, and what everything means, and where KNX actually has made a great achievement in terms of security for home and building control. Without further ado, I would like to hand over the floor to Joost Demarest. Joost, can you tell us a bit more about KNX Secure?
Okay. Also from my side, warm welcome to everybody to the KNX Secure Day. And I've been asked by Christian indeed to do a little technical recap of what is KNX Secure, and also tell you some more about some novelties that we are about to introduce in the field. So my name is Joost Demarest. I'm the CTO and CFO here at KNX Association. So the next slide shows a overview of the content of my presentation. So I will again explain you that KNX Secure exists in two technical flavors. So I will recap what the objectives was of KNX Secure and what does it actually protect against. And of course, then ask the question, how were these objectives reached? So what technical means did we use to reach these objectives? And I also want to underline that KNX Secure itself is a standardized solution. It makes use of standardized security algorithms, but the solution itself is also standardized. And hot from the press, KNX Secure was also evaluated by a worldwide renowned certification body, VDE, and I will tell you about the results of that. And I will also give a small recap of how security is used in ETS 6, the latest generation of our design and configuration tool for KNX installations. Without further ado, let's get going with the first part. So I will again explain you the different flavors that have been put into existence as Christian said it, an extension to the current KNX protocol. On the one hand, we have said that when transporting messages across a IP backbone, the members felt that we needed a solution to better protect this traffic. So, as you see in this picture, when traffic is sent from one IP coupler to another, and also from an IP device to an IP coupler, this traffic should be completely secured. So the entire KNX IP frame, KNX Net IP frame, should be encrypted, meaning someone who does not have the security key cannot interpret the data. Also very important, also to be seen on this picture or in this picture, is that the traffic between the ETS and the IP interface, so the IP tunneling interface, also this part of KNX Secure protects this traffic. So anybody eavesdropping on the configuration or the access from ETS to an IP interface is also protected. So that is the part on KNX IP Secure, securing IP traffic. And also, of course, with KNX Secure, we wanted to secure traffic between two end devices. So if you look in the picture here, you see an end device which is sitting in one line, which happens to talk to an end device in another line. The traffic along the way should be completely secured. Of course, I've already touched upon the securing of the IP frame. This is covered by the other part of KNX Secure. But the traffic, so the group communication between the end device on the left-hand side and the end device on the right-hand side, is secured by the so-called KNX Data Secure. It encrypts the message code and it encrypts the payload. That means that the information on who sends it and to whom it is sent is not protected. So it is still in plain, but the message code and the payload are protected. And the protection is such that in the case where even you tamper with the plain data, so the source address and the destination address, even then the receiver can detect that. So in this picture, we show that KNX Data Secure and KNX IP Secure go hand in hand. And the ETS is there to handle the key management, so the creation of security keys and the, well, putting the keys into the devices, so the distribution of the keys. So the ETS downloads these links in KNX Secure devices independent from the KNX Secure types. So meaning the ETS can handle KNX IP secure devices and can handle KNX Data Secure devices. Okay, so maybe back to the question, what was actually the objective or the scope of KNX Secure and what problem does it actually solve? Actually, it solves three different elements. It prevents from, this is shown in the above picture, it prevents from somebody eavesdropping on the communication between a user and a recipient. So somebody listening in on this traffic and actually recording it and actually replaying it again to the recipient. This we wanted to avoid with KNX. So say you would have an unsecure communication between a sender and an actuator, and you would do group communication. So you could record these telegrams, and then you could replay them, for instance, to open up a gate or a door. So KNX Data Secure prevents against that. Another thing that we wanted to avoid with KNX Secure is that content is manipulated. So, for instance, I send an on command, and I record this telegram as a hacker. I change the on to an off, and I switch off the actuator. So also that should be prevented by KNX Data Secure. And of course, also KNX telegram visibility, meaning that when you trace telegrams on the bus, it should be prevented that someone can simply see the actual meaning of the data. So the KNX Secure should ensure that data can no longer be interpreted by a hacker. So as I've already explained, the application scope of KNX Secure is that communication on IP is secured. KNX communication between end devices across media, be it twisted pair or radio frequency, is secured, and also configuration is secured. Okay, well, KNX Secure, how did we design that? Did we completely reinvent the wheel? Of course, the answer is no, we did not. There are plenty of encryption algorithms out there that have, for the time being, not yet been hacked, so which can still be used to protect the communication between a sender and a receiver. This encryption algorithm that we have chosen is called AES 128 CCM. It's an internationally standardized encryption algorithm. You see the standard is written there, ISO IEC 18033-3. It has a block size of 128 bit, and it has a key size. So the security key by means of which data is protected is also of the size 128 bit. What is the principle of encryption is actually, well, to put it a little bit bluntly, it is actually jumbling up the data so that the data can no longer be interpreted by somebody who does not have the key, and he cannot make out the data. If you want to look at how this is done, this AES 128 CCM, there are plenty of YouTube videos that explain that. Also, if we exchange a key across an unsecure communication channel, for instance, between the ETS and, for instance, the tunneling interface, then we make use of the elliptic curve Diffie-Hellman key exchange. This is also a very renowned way of key exchange that we also use as a basis for KNX Secure. But I have already announced it. So the whole way of using these algorithms and this elliptic curve mechanisms, the way we use that is, of course, described in our KNX standard. But once we have actually completed the specifications, we have also put these specifications into international standardization. So KNX Data Secure, you can read the solution in the EN 50/090-3-4. So we have standardized that via the SANELEC TC205 Home and Building Electronics Systems Committee. And the KNX IP Secure is part of the international standardization of KNX Net IP for building automation. So in ISO TC205, we have managed to standardize our solution as the EN ISO 22510. So anybody wishing to develop KNX Secure devices can also read the solution on how to do that in those two standards. And hot from the press, KNX Secure has also been positively assessed by VDE. VDE is a German active certification body, but it is not only active in Germany, it is worldwide renowned and also worldwide active. So to just put the record straight, this is not a certification of the individual products from our individual members. It is an evaluation of the KNX standard, the KNX Secure standard, and the certification actually confirms that KNX Secure is a state-of-the-art and well-designed security solutions. You see the logos here on the right-hand side. The VDE has confirmed that this solution is the information security of it is tested for both KNX Net IP Secure as well as KNX Data Secure. So the assessment has been done on the KNX Secure specifications and on the current implementation of ETS, so ETS 6. And as confirmed, it is applicable for both KNX Data as well as IP Secure. So that is quite an achievement. So the quality of our standard has been stamped and confirmed by VDE as well. Okay, let's now in the last 13 slides, I want to again refresh your memory a little bit on the implications of KNX Secure in the ETS, and more specifically in the ETS 6 tool. So if when you create as a KNX installer a project in which there is a KNX Secure product, then ETS will oblige you to protect that file, this project file, with a password. And the password can be, of course, 1234, but ETS will point you out that this is not a good idea to protect a project with such a weak password. So if you make the right combination of letters, numbers, and characters of a password, ETS will indicate that this is a good password. Also, for IP devices, for IP tunneling devices, so if you make a connection between your ETS and an IP tunneling interface which is secure, so which complies to KNX IP secure, then ETS will require that you have laid down a so-called management password. So also that can be 1234, but this is also not a good idea. Also there, ETS will point you out, you better use a strong password to connect via IP to your IP secure interface. And also you can use an authentication code, an additional authentication code. This is optional, but it is also recommended. Important when you integrate a KNX device in a KNX secure device into your ETS project is that you will be required to add a so-called device certificate or a factory default setup key. Well, as the word says, it is a key used to set up a device and a key which is shipped, so to say, inside the device, which the device will recognize as being the correct key to set up the device. And of course, needless to say, ETS will keep these FDSKs in its project. It will store it, and any other key that it will create for group communication, it will also store in the project. And it will keep this in a list which you can view under the project details. If you want to export these keys, so the group secure keys and the device keys, then you can make use of the function which is called backup keyring. I've depicted that here in the slide. It's like a keyring that you have in your pocket and which collects all the keys to your home and to your safe or whatever. So also that you can export separately. So you can either hand over the project as a project file, as a KNX XML project file, but you could also separately hand over the keys by means of a so-called keyring file. And in here, you also have the possibility to add additional device certificates. So imagine you would add a KNX secure device to your project. Then you would have to press this plus sign to add a device certificate. And this slide shows you what happens then. So the ETS will activate your camera on your laptop, and you will be able to show ETS the FDSK, which is normally stuck on the KNX Secure device by means of a QR code. And ETS will read out this QR code, which will fill these this row. So this row here, which is actually the representation of the QR code read out by the ETS. ETS allows you, should there not be a QR code on the device, you can also input this FDSK manually into this field. If you should already have included this device in your project, then ETS will also point this out by, as you can see in this slide, I had already this device certificate in my list. ETS says you don't need to import this device a second time. It's already existing in your project. Okay, in the case where you would need to export the security keys for group communication by your KNX IP tunneling interface, you don't need to export the entire project keyring, but you can make a dedicated keyring for just the visualization software, which is going to use this IP tunneling interface for communication. This is very important because this IP tunneling interface needs to be recognized by the receivers as being a valid sender of information. So very important if you want to export these security keys to a tunneling interface. Also, when you integrate IP routers, then also important, as I have already told you, the devices will, in case of IP tunneling interfaces, they will need a password. But when IP routers communicate to each other, then so imagine you have an IP backbone and you use 14 IP secure routers, and you add a non-secure IP router to your installation, and you have set the security mode of your IP backbone to activated, so you want your backbone to be secured, then ETS will not allow you to add this 15th unsecure IP router. In the case where you have put it to, for instance, automatic, then ETS will actually ask you the question, are you really sure that you want to make this backbone again unsecure? And it will put all the 14 other IP routers again to unsecured. Of course, needless to say, you will have to again re-download the whole installation. So it's very important. This security level is also very important that you put that to the right setting, whether you would like your IP backbone to be secured or not secured. Yes, this I have already told you before. So in case of an IP tunneling interface, if you want your IP tunneling interface to be able to of course, in the assumption, of course, that your IP tunneling interface supports security. If you want it to be able to talk in a secure way to receivers, then you need to also assign these group addresses, these secure group addresses, to this tunneling interface. This is very important. And as explained before, for this, you will be able to make a separate keyring export file. In this slide, I have given you a snapshot of how you would be able to see the traffic in case you connect to an ETS project and you open the group monitor, and this ETS project would not have the proper password. In the upper screenshot shows you the traffic where actually you are unable to interpret the user data because you don't have the proper password to be able to view the data. In case you open up your ETS project and you give the proper password and you start your group monitor, then, and of course, if you use an IP secure tunneling interface, and also you have provided the right password, you will be able to see the user data, which is interpreted according to your project group addresses. Very important also, the same phenomena also applies to group addresses, which I explained to you for KNX IP routers. When you create a group address and you decide, okay, this group address must be secured, then ETS will, when you drag new communication objects onto this group address, ETS will oblige you that this communication object is an object of a KNX Data Secure device. If you drag a communication object onto that of a non-KNX Data Secure device, then ETS will say, sorry, you can't link this communication object to a secured group address. This is not possible. So you really have to decide in ETS when you make use of KNX data security, okay, I want to impose KNX data security, or I don't want to impose KNX data security. Okay, a novelty which is introduced by ETS 6, and manufacturers are working on such hardware solutions, is the so-called KNX Secure Proxy. What is a KNX Secure Proxy? Actually, this is a coupler extension that couples a KNX secure line or even a secure segment with a non-secure segment. I will explain you in the next slide what we actually mean by segment. So this is a device which acts as a middleman to convert plain messages to secure and vice versa. So secure to plain. And also very important, it blocks the configuration from the secure side of devices in the unsecure segment. Let's put a picture to that. Just imagine you have a KNX radio frequency domain, which you want to secure, because as you know, the KNX radio frequency communication is out in the open. Anybody can read this traffic. So you don't want this traffic to be hackable. So you decide that this communication needs to be secured. Okay, but you have a twisted pair line, which is buried safely into the wall. So you would like to have a device that actually translates this secure communication into unsecure communication, because you know that a hacker is unlikely to have access to your TP lines. Then you will need such a KNX Secure Proxy. This could be, for instance, a twisted pair radio frequency media coupler. This could even be a twisted pair coupler, or this could be even a twisted pair segment coupler. I will explain you in the next slide what actually this segment implies. This segment is actually before in ETS 5, you were confronted with the rule that if you designed or you created a secure group address, that this secure group address was secured throughout the entire installation. But because of the introduction of the KNX Secure Proxy, so we can have a secure segment next to an unsecure segment, remember the last slide, then we need this previous golden rule is now broken. You can have a unsecured segment and you can have a secured segment. So inside the segment, the communication is secured. Behind this security proxy, this segment is unsecured. Okay, let's again put a couple of rules of thumb as a summary on the table, really summarizing the KNX Secure very well in only 4 rules. So the first rule is the rule I have just explained. Within a KNX security domain, communication using a specific group address is either all secure or it's all plain. You can't have a mixture of both. In the case where there is no security proxy in the installation, this rule applies to the entire installation. So if one device in the domain does not support security and you want this domain to be secure, then the plain device must be exchanged by a secure device. The rule of thumb number 2 is that there is a single key per group address within an installation. Technically, this could be different, but for ETS simplicity reasons, we have imposed this rule in ETS. The third rule of thumb is that for simplicity reasons, ETS only supports authentication and confidentiality. So it means that if a sender sends something to the receiver can verify that the message is really sent by this particular sender, authentication, and the receiver can decode the encrypted data. And this rule applies to all data security communication inside a KNX secure installation. And the last rule is devices with and without security can perfectly coexist. So existing devices, they simply ignore KNX secure messages. So there is no harm in having 90% of your installation simply unsecure, of course, taken into account the precautions that have already been explained before, and to have maybe 10% of your installations, for instance, a radio frequency segment, completely secured. Okay, I hope this has been a brief but still complete recap of KNX Secure, the implications technically, as well as the implications on the ETS, as well as the novelties of standardization and also having had the KNX Secure Solutions solution certified by VDE. I hope I have been able to be as complete as possible. I hand back the floor to Christian. Thank you very much for your attention and enjoy the further KNX Secure Day.
Thank you very much, Joost. Before you leave, I still have some questions for you, because the presentation was very comprehensive. You covered actually everything from A to B and went even like into depth. So thank you very much for that. I still have like the following questions though. You pointed out that all the security functions, all the KNX Secure functions, they are available in the ETS 6, right? Just maybe for a complete understanding for also the audience, KNX Secure projects that have been commissioned in the ETS 5, can they also be still further configured in the ETS 6?
Naturally. So ETS 6 adds the new concepts of the segment coupler and the secure proxy, but apart from that, it's as usual from KNX. You can, of course, convert your data and extend it further in ETS 6.
All right, great. Another question that I would have here is in regards of standardization. So we know that KNX Secure has been approved as a standard and as also a level of certification for VDE. Could you just quickly maybe explain what that means for the KNX community? We have many system integrators here that now know that KNX Secure is a great way of securing your smart home and smart building installation. But this standardization as such, what does that actually mean? What further benefits does that actually bring to the system integrator?
Yeah, so the standardization implies that the technology or the solution is there to stay. So it's not a quick and dirty solution that has been developed by KNX and that is just used by KNX, and the next thing is KNX just turns it upside down, and it is the reassurance towards the installers and to the public that this technology is open and is available to any manufacturer interested, and is also there to stay, because standards are mostly extended, they are not scrapped. And an important aspect of the certification is that in spite of the many times that Christian Staan says that KNX Secure is a brilliant solution, that a third party, which has completely nothing to do with us, has looked at the technology, has looked whether this technology is really does not only pretend to be secure, but is really state of the art and uses mechanisms that really protect your data. So it's actually it is a stamp of a institution which is independent from us that we have done a good job.
Okay, good. That actually concludes the fact that you, respectively, all the developers at KNX Association, they have done the homework. Indeed. Congratulations to that, to like achieving like the standardization. I think this is something that you definitely can be proud of. Maybe also like right now riding on that wave about you having done your homework. Now it's maybe the chance to appeal to all the KNX community, to all the system integrators, to all the manufacturers. Is there something maybe that you wish them to do, to understand in terms of KNX? What are your wishes for the KNX community?
Yes, well, since it is the KNX Secure Day, I cannot stress more that people should really look at the aspect of security when trying to fulfill the wishes of their users, and use the many hints that you find in our a documentation about securing an installation. So I think it has been told or explained in detail today, but I cannot stress more. Please use the means that we provide to you with already very simple means. You can do a lot to prevent people from entering into unnecessarily tampering with your data and your installations. I think if the methods are used, this will also prevent from a lot of headaches also from your side as an installer.
All right, good. Thank you very much, Joost. Thank you very much for all the time, all the explanations, and also like the question and answer round at the end. That sounds very great. We definitely stay in touch for more updates. So feel free to follow us on social media. I think Joost will also be involved in that. And now for the further part of the KNX Secure Day, we shall now move on to the second panel discussion, where we're going to discuss about KNX Secure and also how it has been put into practice by KNX Association. So stay tuned.